but when you have penetration more than 20%, and when it goes up more than 20%, that's where the real power quality problems comes into the grid. All right. So these are some of the results that we have obtained. So for example, voltage flickers. So we have done a study before commissioning. So if you're on your left, it's all before commissioning. The one on your right, which is all red, is after commissioning. So before commissioning, it's all perfect. Nothing all fulfills the requirement. But after commissioning, it's all gone haywire. And you can see all the one in the red has exceeded the specification. Okay, so this is something that we would like to see why this is happening. We have a lot of problems, especially on the flicker. All right, so this is another example. Before commissioning, everything was perfect, and after commissioning, the flickers is exceeding the given specification. And in terms of THD, we have this data was taken on a factory that is producing PV panels. Okay, in Malaysia we have done some testing. This is a PV panel manufacturer. So they want to do a study on the THD, and because they want to install a few panels on the rooftop. So before they install the few panels in the rooftop, they want to do the power quality study. So we did before commissioning and after commissioning. So we noticed that there are some problem. Before commissioning itself, we already have some problem. So you can see there in the slide, before commissioning, the maximum current is about, maximum THD is about 5%, which is exceeding the specification. And after commissioning, it increases further, okay, from 5% to 6%. Okay, so if you look at the chart here, the x-axis is the timing. So you can see if you look at the timing, so it's after 10 p.m. the solar radiation comes up, and this is where the THD increases, and after 4 p.m. it goes down. So this is where the THD exceeding the limit, okay, where there's a lot of radiation. So we have come out, we have a lot of standards, but as you know, that standard is not mandatory things to implement. Standards are basically guidelines for you to follow, right? So we have Malaysian standards we call installation of grid connected photovoltaic system. So we constantly revise these standards, and now at the moment we are doing a second revision for this. So what will be the possible planning and solution for maintaining grid stability? Of course, every problem has a solution, and one of the solution will be the energy storage system. So this is where the batteries, compressed air, and pump hydro come into the picture, and especially the batteries. So today morning, Dr. Shankar was talking about batteries, what we are going to do on the second life of the batteries. So this will be the one of the main good application of second life battery. So there are people who are working on this, where they use the EV batteries. Okay, so because for energy storage, for renewable energy, you don't have to have a very good battery. It's just of storing energy and releasing it. Okay, but for PV, for EV especially, you need to have a perfect or good batteries because you are driving the car. In this case, it's just an element to store energy. So you can use all the PV batteries, provided it is still healthy, right? Still healthy. So this is where a lot of research is being done to study the health of the EV battery. Okay, so we call it a state of health or remaining useful life, RUL, of the battery. So if you feel that it is healthy, safe, and can be used, so will be used for renewable energy application, especially for solar energy storage. So weather forecasting technique is another solution. Power electronics converters, you design it properly in order to make sure that we are not compromising the power qualities. So these are some of the solution. Microgrid is another example of how we can take care of our grid. monitoring is something that everybody is focusing to, especially the SCADA system. So every country, I think all the power systems here, we have the SCADA system where we can monitor the grid frequently, right? So I think this is all I want to deliver for this talk, and maybe we can have questions from the floor. I hope my presentation does not bore you too much, because it's a little bit technical. Some of you may understand, some of you it's something new for you. That's why I try to make it as general as possible. I know some of you are working on power electronics. Yeah, I think I can hear you.
If the penetration is more than 20%, it may have a problem in the grid. So what are the expected problems in grid if the penetration is more than 20%?
Grid stability. So grid stability, we have to make sure the grid is stable, okay? So if you look at the grid, the two important criteria that always they monitor is the voltage and the frequency. Basically, the grid voltage is, the grid is what frequency and the voltage. So either the voltage increases or decreases beyond the limitation, or the frequency increases or decreases beyond limitation, is either 50 hertz or 60 hertz. So these are the things that can cause us the grid to collapse.
So this 20% benchmark is from any standard, sir, or?
No. This is based on literature. So people have done study in Germany especially. So we always benchmark Germany because Germany has higher penetration of renewable energy. So they have done some study to show how many percent of renewable energy it is safe or does not cause any power quality issues. So they found out that anything less than 22%, it does not really impact to the grid. Anything more than 20%, there is a chance for the renewable energy to disturb the grid.
Is it the 20% limit is with respect to the size of the grid? Say, for example, if
20%
it's an Indian
of
grid or a Malaysian grid or?
No, any grid, general. So 20%, that 20% means renewable energy penetration.
Yes.
So you're reducing the fossil fuel, in this case maybe coal, by 20%, because we know that coal plants are already, they are stabilized, established, all right?
Yes, sir.
Okay, so now we are injecting solar energy or wind energy into the grid. And these are all DGs, distributed generators. They are not in one place, they are all over the countries. So when you're injecting the power to the grid, when your power is not clean, so you're going to affect the whole system, right? So this is what I'm saying. So 20%, anything less than 20% is very little compared to 100%. So if you go and higher, the more problem that you're going to cause in this one. I'm not saying that whenever you go 20%, there's always a problem in the grid. So this is why from what they have done research, anything go above 20%, please be careful. So this is why every country is coming out with all the regulation to make sure that in the future they don't have problem. Don't assume that whenever above 20%, the grid is going to collapse and there's going to be a lot of problem. No. So we are taking precaution, all the countries are taking precaution, so that if you go more than 20%, you can have problem when you reach 10% as well. I'm not saying that 20% is what they call the line that you draw. You can have problem when it is 10%. For example, I'll give you one example, is in Thailand. All right, so they had this problem very early 2012 or 2013, where all the solar plant is concentrated at one place. So when the solar power is intermittent, right? So when the solar power is intermittent, so there is power to the grid and there is no power to the grid, and it fluctuates. So when it fluctuates, the grid also fluctuates. Okay. So when the grid fluctuates, the whole grid in that region collapse, because you cannot have fluctuation in the grid. You can have fluctuation in the grid, but provided within the standards. That's why every country have come up with the standards, plus minus 5%. The voltage should not be more than plus minus 5%. So as long as you within the limit, you should not have the problem. So most of the countries are coming up with the regulation so that in the future they won't face the problem.
So, and something in literature, I have seen that 100% penetration of renewable energy, like that some of the papers I have come across. Is it really possible in future?
Future, yes, but not now, because we are still depending on, you cannot get 100% renewable energy in a country. For example, India, we talk about India. There are certain parts of India that you have wind, and certain parts of India you don't have wind power speed and so on. And for example, I give you a Malaysia. Malaysia, we don't have wind. So what we are going to depend on? 100% on solar? I don't think so. A country will be depending 100% on solar. If something happens to the solar system, what will happen? Okay, so another 40 to 50 years, the fossil fuel will be there. Don't worry. Okay, the coal will be there. The natural gas production will be there, and so on. But we are just only to try to reduce the fossil fuel and to increase the renewable energy.
And only one small clarification. So you were talking about the THD, harmonics, and IEEE suggests that it has to be below 5%. And really, what is happening if harmonics is injected into the grid? Is there any problem with which component it is affecting in the grid?
No. Let's say you have a system that injecting power to injecting harmonics to the grid. So your injection is very, very, very little compared to the whole grid system. So at the moment you don't have problem. If you're one person injecting to the injecting THD higher than 5%, there'll be no problem. But imagine everybody here is injecting more than 5%. So this is where the THD is getting higher and getting higher. So once the THD is getting higher and higher, it's going to affect especially the motor drives. Okay, the motor system is very fragile. The drive system is very fragile. So you cannot. Basically, if you look at the definition of THD, is how clean is your power. So when you give for example, I'll give you a very simple example is water. What happens if you get dirty water from the supply? So you have to clean it yourself, right?
Yes.
So this is where another cause. So if you don't clean it yourself, you consume, you get sick, you get a lot of problem. So this is something that I can relate to. Okay. So THD mainly affects the power electronics devices, especially. Okay. On controllers. Okay. Controllers are very fragile. So if you have higher THD, your controllers can affect, and eventually it will affect to the motors and so on.
Thank you very much, sir.
All right. Thank you. Any other questions?
would like to extend our heartfelt thanks to Dr. Jairaj for his enlightening session. Thank you, sir. Thank you all for attending. Refreshments are available outside the auditorium, and next session will be commenced by after 15 minutes. After 15 okay, sir. Track will commence after 15 minutes at the corresponding venue.